find out displacement, knowing the conditions of initial velocity, final velocity. So displacement time and other factors can be calculated. So in the first chapter, basically we had done the description of motion. We were doing how to describe motion. Okay. Now in this chapter, what happened? In this chapter, we are studying the cause of the motion. So conditions under which the motion is possible, conditions under which there will be different types of motion. So if you are having a uniform motion, it simply states if you have a uniform motion means there is no acceleration. Am I correct?
Yes, sir.
Yes. So here we are doing interpretation.
Yes, sir.
Yes. Okay, you people should keep your camera on. Those whose cameras are on. Okay, see, actually what happens during the class, whoever's cameras are on, they are the first one who are in the query. Okay, if I want to ask anything, so I generally look up their name comes first over here in the list. So to be an active participant, you must keep your camera on. Got it? So here we are interpreting the second law of motion, which stated we have force equals to mass times acceleration. We have force given by ma. So we have force equals to mass times acceleration. So acceleration would be equal to force over mass. Now, once we know the acceleration, so we can relate this chapter with the first chapter. Got it? So if there is if you apply some amount of force on an object,
Sir, here
yes,
we have to use the acceleration formula, right?
now see everything is linked. Whatever you have studied up to now, you have studied v equals to u plus at. You have studied s equals to ut plus half at squared, and you have studied v squared minus u squared equals to as. So by considering these three, you can see we are now relating the cause of the motion. That means if you are expecting any change in velocity, which is acceleration, see, if you are expecting an acceleration, that means if you expect any change in the velocity, okay, so there will not be any change in velocity and hence there will not be any amount of force required. Just look at this. If I make a force to be equal to 0, if in this expression I put if force equals to 0, so I have acceleration also 0. There will be 0 acceleration. And if I use 0 acceleration in the first equation of motion, I'll be getting here v equals to u plus 0. That means v should be equal to u. So can I say that initial velocity will be same as the final velocity? Yes? Yes or no? If the force is 0, so can I say that initial velocity and final velocity would remain the same?
Yes, sir.
Yeah. So will there be any acceleration?
No, sir.
No, sir.
No. There will not be any acceleration and hence the object will continue to be in its state of uniform motion or in the state of rest. So which law of motion stated this line?
So the
First law of
second
motion.
first law of motion.
Yes. So first law of motion stated that if there is no external force acting on an object, so the object will continue with uniform velocity or it will continue to be in its state of rest or of uniform motion unless acted upon by an external unbalanced force. So here it is
Sir,
proved
if
from the second law of motion. Yeah.
Sir, then if the initial velocity will be equal to final velocity, then we can blindly say that the force will also be zero.
Yeah, we can apply force is zero. We can say that the net force is zero. Okay. So can we conclude that the first law of motion is included in the second law of motion?
Yes, sir.
Yes. Since everything, whatever we are getting from the first law of motion, the same thing we are getting from the second law of motion also. The second law of motion proves it mathematically and tells us that yes, first law is valid. Whatever we have done in the first law is valid. Got it?
Yes, sir.
Yes.
Understood.
Yes. Now, another thing, see, there are many different things which we can obtain from this as an interpret from the second law of motion. Okay. So we will try to understand a number of factors from the second law of motion. Okay. So see, we know that acceleration is given as v minus u over t. And from here, I can obtain that acceleration is inversely proportional to time. Am I correct? That acceleration is inversely proportional to the time within which the change is obtained. Yes?
Yes, sir.
Yes.
Yes,
So
sir.
we can see here that the time is inversely proportional, acceleration is inversely proportional to the time. Okay. Now see, consider, I think all of you must have seen, you must have practiced catching a cricket ball. Okay. Or consider different examples. For example, you have here, you are jumping off from the top of a building. Okay, this is a building and you are jumping off. Don't try to jump from the building. Okay,
Yes, sir.
just in physics, we are imagining to jump, you are jumping from the building. So how many of you will be ready to jump off? Is there anyone who will be ready to jump off from the top of the building?
No, sir.
No, sir.
Okay. Now what I do, I put some cushion over here. At the bottom, here I put some cushion. Okay. Then can you try out to jump? If you have some cushion over here.
Yes,
Sir,
sir.
wishes. Yes, then, sir, we can.
So why? What is the difference between the two? If you are having a
Sir,
cushion over, yes.
Sir,
sir, while we do not have a cushion, we have more impact from the ground. Means the ground is applying opposite force on us, which is more than us, so we might get injuries. But in case of cushion, no, sir, it applies a less force.
Yeah. You are correct. But how it is that when there is
Sir,
no
this is
cushion,
due to the third law of motion where every action receives equal and opposite reaction.
okay.
So,
So,
sir, if we jump off a building without any bushes, we will have more impact.
so
But
why
if
more impact? Why more impact and why less impact?
Sir,
Why?
because the
sir, because
contact, the
this
area of contact is increasing.
very little, sir, when bushes are not there.
Okay. Can you apply here these two things? I have written over here one of the formula that acceleration is inversely proportional to time. Now I'm writing another
Sir,
thing here.
doesn't jumping off the building also depend on the person's mass?
Just 1 minute. I have here F equal to ma. Now, can you
Yes,
predict the force that will be experienced by a person who is jumping on a cushioned surface and by a person who is jumping on a hard surface?
Sir, is it due to, sir, when while we reach the cushion, the time interval is less, and while we reach the ground, the time interval is more?
Yes, see what happens here. The role is of the time interval which is there for bringing about the change in velocity. The time interval required for stopping the object when you are jumping on this cushioned surface. So once you jump over here on the cushioned surface, you do not stop instantaneously. When you jump over here, your body goes deep inside along with the cushion, and then cushion rises up. So whatever change of momentum is brought about here, okay, it takes some amount of time for the cushion to go down. Here it takes some amount of time for the cushion to go down. Okay. And when it is hard, when the surface is hard, so the person jumps on the ground, but he stops instantaneously. The time taken for bringing about the change in velocity is very small. Okay. So if you have on the hard surface, and the second case is on the cushioned surface. On the hard surface, the time is almost zero, almost zero. Instantaneously, you are coming to a stop. On the cushioned surface, you are taking some seconds, a few seconds to stop. Okay. So now, just because of this difference of time, the amount of acceleration will be different. For the cushioned surface, the acceleration that will be offered will be less. There will be less acceleration because of high amount of time. Maybe it takes 3 seconds, 2 seconds for you to stop. So acceleration will be small. If the time is large, acceleration will be small, and hence the force will also be small in the case of cushioned surface. Okay. But if you are falling on the hard surface, the time is very small. It's about a few milliseconds. The time is about a few milliseconds or microseconds. Within that, there is a lot of change of velocity. So acceleration is very large. It may be about 1,000 times higher or maybe 10,000 times higher. So the difference over here in these two cases, here acceleration is high. Why acceleration is high? Because it takes a very small time to stop. And in this case, acceleration is low. For a cushioned surface, if you are falling on the cushioned surface, acceleration is low. If you are falling on the hard surface, acceleration is high. Now, if your acceleration is high, so force will also be high depending on the formula F equals to mass times acceleration. Okay. Here, force will be low. Again, depending on the formula, force equals to mass times acceleration. So you will have a small amount of force over here. Got it? Yeah.
Yes, sir.
Yes, sir.
Okay. Now, can you explain me another similar example? Let me a similar example that takes place. A fielder catches a ball, or a wicket keeper catches a ball. Okay. So I hope you must have observed a wicket keeper catching a ball.
Yes, sir.
Okay. And do you observe him pulling his hands backward?
Yes, sir.
Yes.
So why does he do that? Why he has to pull his hands backwards?
So that he can catch the ball.
What will happen if he doesn't move, make his hands backward?
Sir, the ball would have like less time for the force apply, no sir. So it might slip also. But while he is moving backwards, the time interval is more. So the force for the ball will be less.
Time interval is less or high?
Sorry, sir. When moved backwards, it's
Sir,
high. When
more.
it's less.
Okay. See, consider a wicket keeper or any person who is catching a ball. So let's say my drawing is not that good, so I can't draw your hands. So here, if the person catches the ball and if he moves his hands backward, so the time taken for the ball to stop is small. You have a very less time. Here time is large. It takes some amount of time for the ball to stop. Whereas if he doesn't move his hands backward, if he catches the ball at the same instant, so the amount of acceleration has to be brought about in a very small amount of time. Change of velocity here, t is small. It has to be stopped in a very small amount of time, whereas here it has to be stopped in a large amount of time. The time is large. He increases the time. So the amount of change of momentum that has to be brought about. It is
Sir,
brought about, yes.
sir. So, if he stops at instant, then the keeper should have applied more force. But while dragging, he can apply small force, sir.
Yeah, here with a small force he is able to catch up, and here he has to apply a large force, and hence he might get injured. There are chances that he might get injured if he is not pulling it backward. Got it?
Yes, sir.
Okay, another thing, another question similar to it. Just let me see if you can answer. Think of it, think of it for 1 minute and then start answering. Okay. So my question is, why do we have shockers or shock absorbers in vehicles? So what is the role? How do they work, shock absorbers?
Sir, they absorb the intensity of the accident or something.
Yeah, what happened? Just think of it. Think of it for 1 minute and then tell me the answer.
Sir, can I say?
Yeah.
Sir, if we have shock absorbers in vehicles to increase the time period, uh, for the force to reach us. If we don't have shock absorbers, then the force is more and impact on us is also more. But when we have shock absorbers, the impact on us is less.
Okay. Very good. Rohit, can you answer the same question?
Yes, sir.
Yeah.
Sir, they have shock absorbers so that they can compress the suspension of the car so that the car doesn't lose its suspension.
Uh, you are not using any physics.
Yes,
You are just using your literature.
yes, sir.
Okay. So use your physics and then answer.
Sir, because they need to hold the mass of the car, that's why shock absorbers are present in vehicles. Because the
Okay.
car is very heavy, that's why to have balanced force in the car, they have shock absorbers.
Okay. Okay. Jitendra Reddy, are you available? Jitendra,
Yes, sir.
are you available?
Yes, sir.
Okay. So can you tell why do we have shock absorbers?
So to absorb the impact of the accident.
So, okay. Impact of accidents. Okay. How do they do that? Like, yes. How do they do that? Okay. Pranav. Restart. Yes, Pranav. Pranav, answer the question. Why do we have shock absorbers in vehicles?
Sir, can I answer it? I have another answer.
Okay, just 1 minute. Hold on, I'll give you an opportunity. Let me give opportunity to others. Shravan.
Sir, I don't know the answer. I'm just thinking about it.
Okay, you are thinking about it.
Sir,
Yes.
can I say?
Yes.
Sir, they absorb the impact and give it to whole vehicle
Okay, of course
spread.
they absorb the impact, but how?
Sir, it's because they need a time interval to stop the jerk of the car.
We
There's,
need a time interval to absorb the jerk of
so that
car.
the car doesn't jerk while while it's in motion. That's why we have shock absorbers.
So first of all, see, you are all some of you are pretty close, some of you are trying well, very good. So only a few answers I got which are to the point. Okay. So see what happens when you have shock absorbers. So okay, consider this road. You have this road, and on this road you have some jugs. At different places you have some jugs like this. So somewhere you have like this, somewhere you have like this. Okay, so this is a road. Maybe it can be like this. And now your vehicle comes. So this is your vehicle. It comes over here. So there are two vehicles. One with shock absorbers. So the shock absorbers, they are generally springs. You know that the shock absorbers, they are generally springs which are attached to the vehicle. So these are springs. Now when the vehicle comes over here to this jug, so this jerk will try to lift all the vehicle upward. It will try to lift all the vehicle upward. But when you have these shock absorbers, all the vehicle will not be lifted upward. The vehicle will continue to move in the straight line. It is only the spring will adjust its length. So when the vehicle comes over here, the spring will adjust its length. In other words, I can say that spring increases the time. The spring is increasing the time of impact. And when you increase the time of impact, whenever you increase the time of impact, you are decreasing the acceleration. The same concept we used as acceleration is inversely proportional to time. So acceleration is inversely proportional to time. Now, once you apply some amount, once you have some increased time, then acceleration will be less. And if acceleration is less, so we will have a lesser amount of force. So F equal to ma. A small amount of force will be experienced by the passengers who are sitting inside the vehicle. Any other question? Okay, very good, Sampath. This answer is pretty good. Sampath has given a very good answer. I'm just forward.
Yes, sir.
So to be active during the class, it has to be your active nature every time. I'm just putting Sampath's answer over here. And you can go through it. He has put the answer in good words. So this is how I want the answers in your exam papers also. See, can you read it? Shock absorbers are present to increase the time intervals, which reduces the force applied on the passengers, and the momentum is decreased. Got it? Okay. Pranav, now are you aware of the answer? Yukta? Yukta, are you aware of the answer? Okay, so Pranav says again explain. Okay, no issues. So everywhere our ideology is based on these two expressions. You have acceleration is inversely proportional to time. We write acceleration inversely proportional to time, and we use force equals to mass times acceleration. Okay. So once you increase time, if you increase the time of impact, so you will have a lesser amount of acceleration, and less acceleration means a less force. As per this relationship, we can say that acceleration is inversely proportional to time. Got it? Anyone having any doubts? Anyone having any doubts?
No doubt, sir.
Okay. So can you answer some other questions?
Yes, sir.
Okay. So why do you think cushions are why do you think the sand is cushioned for a long jump? For the players of a long jump?
Sir, what?
For the players of a long jump, why do you think that cushions are sand is cushioned over there? Whatever sand is being used. So why do you think the sand is cushioned?
Sir, it increases the time interval for the player so that it reduces the impact on the player.
Okay, so something like this happens over there for the long jumpers or even for the pole vault. So for a long jumper, what happens? You have a long run, and this is the point from where he has to jump. Now, where he has to fall, after jumping wherever he has to fall, so there we will find, here we will find that the sand is cushioned. Okay. The
Yes,
sand
sir.
itself is broken.
Sir, it increases the time interval between the player and uh, it increases the time interval so the player doesn't impact, right? When he
It,
falls.
yes. Yeah, again, just you have understood, but you are not able to just put in the proper words again. Okay, try still once more. So what it, yeah, it increases the
Sir, the
time.
sand is cushioned so that because when the play due to the time interval because if the player jumps too early, the impact will be more. That's why there's a time
Yes.
interval between the player so that there's not so much impact when he jumps.
Yes. So when the player jumps off, when the player jumps, or when the player falls on the ground, so it will increase the time to stop. It will increase
Yes,
the
sir.
time taken to stop, and hence there will be less impact on his body. He will not get injured. If the earth were hard over here, had the earth been hard over here, so what would have happened? It would have taken very small amount of time for him to stop.
Yes, sir.
Okay. So again, Sampath has given answer. So you can just see to it. You are also trying to give good answers. Okay, but see, you can always improve your answer. So here, my question was, why do we use a cushioned sand? And for this, you have this answer. The sand is cushioned to increase the time interval, which results in decrease in acceleration. By decreasing acceleration, the force on the player decreased. Okay. So one thing you can add here, just a small point, results in decrease of acceleration, time interval to stop. Okay. Just this time interval to stop. So this is which results in decrease in acceleration. By decreasing acceleration, the force on the player is decreased. Got it? So see, all these questions, the questions are different, but all their answers are same. Aren't the answer same? For this one, the answer is same. For this one, the answer is same. Okay. The same thing, the same question can be put up in another way. Okay. If you suppose the question is like this: if you fall off directly from a building on a hard surface, you get injured. But if you fall off on a cushioned surface, there is no injury. Why? So again, your answer remains the same. Okay. So have you understood, everyone?
Yes, sir.
Yes.
Sir, I have one doubt.
Yeah.
Sir, in one worksheet, it's given like which law of motion expresses the measure of force, sir. What does it mean?
Just pardon.
Sir, it says which law of motion expresses the measure of force.
Okay. So it's the second law of motion which gives the measure of force, or it gives us the quantitative measurement of the force. See, the qualitative idea of the force is given in first law of motion. That means what is force, how it acts, those different things, they are given in the first law of motion. But the quantitative idea, how to measure the force, what will be the amount of force that is acting on an object, that we learned in the second law of motion, where we studied. Nikit? Okay, so here it is given that force will be equal to the rate of change of momentum. Okay, so force is proportional to the rate of change of momentum, which will be given by the second law of motion. Okay, so this question is typical. If you are asked, sometimes it is asked, which law of motion gives you the definition of force? Okay, so which law of motion gives you the definition of force?
Sir, the first law of motion.
Yeah, first law of motion gives you the definition of force. And the law which gives you the measure of the force, that is the second law of motion.
Okay,
Got
sir.
it?
Okay.
Okay. So I think all of you have understood all these examples. A, a cricket player catching a ball. Okay. Uh, Action or role of the shock absorbers in vehicles. We have seen why the surfaces are cushioned. If you for a high jump or for a pole vault player. All of you, how many of you know about the game pole vault?
Sir, they jump using a pole, that one.
Yeah, jump high with the help of a pole. The players jump very high with the help of a pole. Okay, so at the maximum height when they reach, from there they leave the pole. They leave the pole and then jump on the ground. So
Yes,
that
sir.
is the game of pole vault. Over there again they need cushions. So cushions are provided for them so that they don't get injured for it. Okay. So I
Yes,
think
sir.
with the role of physics, everyone has understood and everyone can explain the action of the second law of motion. Sarvan,
Yes.
Yes, sir.
okay, why
Yes.
your camera is off?
Sir, I'm a new student. I just joined today.
Okay, so okay, you are not aware, right?
No, sir. I just joined today. It's my
Okay,
first
okay,
class.
Okay. So during the class, keep your camera on.
Okay,
Okay.
sir.
You can
Okay.
use some backdrop if it's possible. If not, there are no issues. You can keep it as it is. Okay.
Okay.
Yeah. So when you keep your camera on, every time when I ask any questions, I'll be able to catch you up that yes, you are there.
Okay.
So just keep your camera on. And we are doing here second law of motion. So I hope you are aware about the first law
Yes,
of
sir.
motion. Okay. So if you are
Um,
facing, yeah, any doubts?
no, sir. For second loss. Okay. Okay.
Okay. So if you are getting any doubts, if you are having any questions from your side, like even some of the questions are there which you are not getting, so you can answer, just interrupt me at any time during the class.
Okay, sir.
Okay.
Okay.
And be regular with your class. Join every day at this sharp timings. Okay,
Okay.
Yukta, Jitendra Reddy. Jitendra?
Yes, sir.
Okay, so what about you? Have you understood?
Yes, sir.
Okay. So with the second law of motion, these are the different things where we can explain that the rate of change of momentum should be directly proportional to the force, or you can say that the acceleration is inversely proportional to the time taken for to bring about the required amount of change. Okay. Now let us say the third law of motion. Once we observe the third law of motion, it's a basic law of motion, and third law of motion is also explained by the second law of motion. Okay. So for the third law of motion, see, okay, see. So let the third law of motion. So see, in your complete physics, if you are able to understand this third law of motion, this is a very important law, third law of motion. It seemed to be very easy. The statement of this may seem very easy, but it's very complicated to understand this. It's very difficult to understand what actually we want to say here in the third law of motion.
Yes, sir.
Okay, if you are aware, if you can very well utilize this third law of motion, then there is no doubt that you will be able to complete, you will be able to grasp around 80% of your concepts from grade 11 just because of the third law of motion. So you can expect how important this law of motion is. The statement of the third law of motion is quite simple. The
So
statement,
every action has an equal and opposite reaction.
yeah. So this is what we all know. Understand this. We see every action, and then I will ask you a question also. So you have every action has equal and opposite reaction. So if you are able to answer my question after this explanation, then it must be clear that yes, you have understood. Every action has equal and opposite reaction. Now, so what are the different concepts that are being cleared here?
Sir,
Action and reaction. Okay, action and reaction. These are the two forces. These are the names of forces.
yes, sir.
Okay, and there is nothing, something cause and effect like that. It's not cause and effect. It's not that one of the force first act and then the second one act. There is no delay between the two forces. Action and reaction, they act at the same time, at the same moment. So you can always say that forces always occur in pairs. Can I say? Forces always occur in pair. Okay. You can call either of them to be the action force and either of them to be a reaction force. Now, to understand this third law of motion, let's try to do a small activity over here. So you have your floor, and let's say you have a wall over here. Now, by wearing roller skates, so a kid is wearing roller skates over here, and this kid, after wearing the roller skates, he tries to push this, he tries to push this wall. Okay. So can I say that the kid is applying some force on the wall?
Yes, sir.
Yes, sir.
So the kid is applying some force on the wall. Okay. Now, what do you think? Who will move? Wall will move or this kid will move?
So the skid will move because the wall is not. Uh, so the skid will move more because there's no external force being applied on the wall. That's why.
So the kid will move backward or forward?
So it won't move at all.
See, the kid is okay. The kid is pushing
I
this wall. The
So
kid
the
is
kid
pushing
will
the
move
wall.
backwards because when he pushes it forward, he'll get an
Mhm.
opposite reaction where he'll get pushed backwards a little.
Yeah. So will the forces be same or be different?
So it will
Will
be
he
different.
experience? It will be
Sir,
different.
it will be same.
It will be the same.
Yes, sir.
Sir,
What
it won't
if
be,
he?
sir, it can't be the same because we're not, sir, because even if we apply a force on the wall, it won't move.
Hmm, okay, wall is not moving. That's a different question.
Yes,
Okay.
sir.
Wall is not moving. That's a different question. But can I say that the boy is applying some force on the wall? Is this
Sir,
statement
yes, sir.
correct?
Yes, sir.
Yes. So the boy is applying a force on the wall. However, the wall is not moving. That's a different case.
Yes,
Okay.
sir.
So the kid is applying a force on the wall, and we observe here the kid will move backward.
Yes, sir.
Okay.
The kid will move
The,
backwards.
the kid will move backward. So who is pushing the kid backward?
So the
Wall.
wall. Because with regard to the statement, when we give the action, when we're doing the action of pushing the wall, it is giving us an opposite reaction by pushing us backwards.
Okay. So this boy, he is getting a backward force. He is getting a backward force if he pushes the wall. If he pushes the wall,
Yes, sir.
so he himself is pushed backward, and that is because of the reaction of the wall.
Yes, sir.
So that is a force of reaction. Everyone
So
has
the same
understood?
thing happens when we punch a wall, right?
Uh, Pardon?
Sir, when we punch a wall, the wall will give us equal reaction, right?
Yes. If you try to punch a wall, so you are applying a force on the wall, and as a result, the wall will also apply a force on you.
Yes, sir.
Sir, I have a doubt,
Yes.
sir.
Yes.
Sir, if we continue to push the wall with the same magnitude and the force, the wall will also push us with the same magnitude, sir. So won't the forces be balanced?
Yes. So this is my question now. This is a question which I would like to ask all of you.
Yes,
See,
sir.
the question is actually this way. I'm just modeling the question in different words. Okay. So if you understand action and reaction, okay. Just before the question, I'm just giving you the question, and then I'll explain it up one more topic with this action and reaction. Okay. So my question is, if action and reaction forces are equal and opposite, so why they don't cancel each other. So why they don't cancel each other? Okay. So this is the question. Answer I will be expecting a little bit after. Let me explain you one topic first. Okay. So you can think of it if anyone knows. So we will ask it. Okay. Um, just one. Did you question mark over here? Okay. So my next problem is over here. Okay. So let us see here again. I'm taking a wall. So every time I'm taking a wall. Okay. Now on this wall, I have a hook. With this hook, I attach a spring balance. So I'm attaching a spring balance over here. So this is one of the springs where I am attaching the spring balance. So as you know that the spring balance indicates the amount of force that is experienced, right? So spring balance measures the force. Now here I use another spring. So from here I use another spring and let's see. This is the second spring which I have used. So these are the two springs. Suppose I am pulling this I am pulling this spring. So on which spring, let this be spring 1 and let this be spring 2. So on which spring am I applying the force?
Sir, on string 2,
Okay. I am applying the force on spring 2 and suppose I am applying the force of 5 Newton on spring 2.
yes,
Okay.
sir.
Then what will be reading on this first spring?
Sir,
Will it
can
be
you repeat the
2.5?
question you asked?
See, I am applying a force of 5 Newton on this first spring. What will be the force on the second spring? What will be the force on the first spring? Will it be, I'm giving you the option, should it be 2.5 Newton? Should this force be equal to 5 Newton? Should this force be equal to 0 Newton? Or should this force be equal to 10 Newton?
Sir, will it be equal to the half of 5 Newton?
Hmm?
Sir, sir,
Hmm?
I think it will be the same because opposite reaction will be given by spring 1 as well.
Okay, see, understand this complete phenomena. Here the spring 2 is pulled, I am applying a force of 5 Newton on the spring 2. So spring 2 will show me a force of 5 Newton as I am applying a force of 5 Newton on the spring 2. And
Sir,
now,
then the force will be 0 Newtons for the first spring.
uh, pardon?
Sir, it will be 0 Newtons for the first string as we're applying the maximum force on the second string, right?
So, won't the second spring pull the first spring towards it?
Sir, then it will become, then won't the force be the same?
Yes. So the forces would be the same. Okay.
So
Here
it's,
the
so it's 5 Newtons for spring 1 as well.
yes. So 5 Newton for spring 1 as well. Now coming to my question, I have got one person's answer. Okay, one person has given me the answer and that answer is perfectly correct. Okay. But I want to understand, I want to get that whether you have understood this point or not. So answer to this
Yes,
question,
sir.
if action and reaction forces are equal and opposite, why they don't cancel each other? Can anyone else think of the answer? Yes, can anyone else think of the answer?
Sir, can you give 1 minute?
Yeah.
Sir, they don't cancel each other because so they don't cancel each other because the same force is on the same force will be applied on the objects which are receiving it.
Ah, see, the forces are equal and opposite. Okay, so I have got answer, and this is from, I have got two people's answer, Jitendra Reddy and Sampath. Okay, both of them, they have given correct answers. Okay, so this time I'm copying both of their answers and providing them to you. Okay, so I'm adding every, I can't add all, but yes, those who answered first, their answers I am
Sir,
adding here.
they don't cancel each other the third because the third law of motion states that every action is equal and gives opposite reaction.
So that is true, but why they don't cancel then?
Sir, because they don't act on the same object.
Yes, because they don't act on the same object, they are acting on two different objects. So these are the two answers. So a few people have given me more answers. I have not gone through them. So there are two more answers.
Sir, does the same answer apply when we recoil the gun?
Yes, the similar thing over there also. But we'll do that in the next class.
Yes, sir.
Okay. Okay. So bye all of you. See you again.
Sir, I had a doubt.
Uh, okay. So you doubt, please clarify in the next class. I have
Yes, sir.
another class now.
Yes, sir. Thank
Okay.
you so much, sir.
Okay. Bye.
Thank you, sir.